Okay, now that we just got done finding our axis of symmetry, okay, we now need to be able to use that axis of symmetry to find our max or our min point, okay, which is basically going to be our vertex. So I know that when we were together, we defined our vertex. Okay, our vertex we said is the highest point or the lowest point, okay? It's the turning point of the parabola. So it goes up, 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 increase, 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 peak, which is our max, and then down, 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 okay? So it's our turning point, and it's our max point, or more specifically, our min point, okay? It depends if it's concave up or if it's concave down. But I know in our organizer, we had our vertex represented in ordered pair, okay? So what we had figured out so far is we figured out that the y value is our max or our min, okay? It's our max or our min depending on if we have a concave up or if we have a concave down, okay? So we left this x part blank. But, okay, if we just covered the axis of symmetry and we figured out that that axis of symmetry, okay, cuts the parabola in half, isn't that max point right on that axis of symmetry? Okay, and we said that this line is x equals. So if this is an x equals line that folds the parabola in half, okay, it's also the x in our ordered pair. Would that be a max or would that be a min? Okay, so that would be our max. So from finding the axis of symmetry, we figured out that our x inside of our vertex represents our axis of symmetry. Okay, so what I like to do is I like to say our vertex is x equals opposite b divided by 2a, aka our axis of symmetry, okay, comma, max or min point, okay? So, today's video is going to be over, can we find our max point or our min point, and then can we put both of them together to say our vertex of this parabola is blank, okay? So, let's start off with one. Let's do y equals x squared minus 6x plus 5, okay? Y equals x squared minus 6x plus 5. So just like before, okay, we have to find our x in order to find our max point or our min point, okay? So start off the exact same. Find your a, your b, and your c, okay? So my a is 1, my b is negative 6, and my c is 5, okay? So axis of symmetry, x equals opposite b divided by 2a. So our b is negative 6. So what's opposite of negative 6? 6 divided by 2 times our 1, because that's a. So we have 6 divided by 2, which is 3. Okay? So right now, just from finding our axis of symmetry, guys, that tells us a lot. Okay? That tells us that our parabola gets folded in half at x equals 3. So if I have this graph over here, right now we should be thinking this. 1, 2, 3. Right here is our line that cuts our parabola in half. Okay? So now our goal today is to find the max and the min and put them together to find the vertex. Okay? So if we go back to the original, okay, can you tell me right away if it's concave up or if it's concave down? So you should be able to. Since this is positive, we know that it's concave up, okay? Since we know that it's concave up, we know that we have a min, okay? So the question is, where is this parabola going to stop on this line? Okay, and the point that it stops at, since we're going up and down, is going to represent a y point. Okay, so we're trying to find the max and the midpoint inside of the vertex. Okay, so to do that, we know x is 3. So if we know x is 3 and we're trying to find y, can't we just take this and plug in our x to then spit out our y? So if we have our y, we'll know exactly how high or how low this parabola gets locked in, okay? So let's do that. So we have y equals x squared, so 3 squared, I substituted it in, I plugged it in, minus 6, oh, there's another x, so I have to plug in my 3 again, plus 5. Okay, so from here, guys, this just goes back to your order of operations, okay? I know you know how to do this. So we have 3 squared, which is 9, okay, minus 6 times 3, which is our 18, plus 5. Okay, then we have 9 minus 18, which is negative 9, plus 5, which is negative 4. Can you see this? Yep. Okay, so now we know y equals negative 4. So if we know x is 3 and y is negative 4, can't we lock this parabola in? 1, 2, 3, negative 4. Okay, so we know that this point is 3, comma, negative 4. We also know that that point is our min, and since we know it's a min, that's the same thing as our vertex, the turning point. Okay, so our vertex is 3, negative 4. Our axis of symmetry, comma, our top or our bottom point. Okay, so 3, negative 4. So this would be, since we know it's concave up, again, the marble would get stuck at the bottom, so it's our min point. So we found our axis of symmetry, our line, okay, and then we plugged it back in to spit out how high or how low it gets locked in on the axis of symmetry, and we found that to be negative 4. Okay, so let's try another one. We'll go through like 2 more, and then I think honestly you'll be good to go. So remember, your vertex, okay, your vertex is your axis of symmetry, comma, max and min. So what I like to say, it's your axis of symmetry, plug in, spit out, okay? The only way that you can find this max or min point, guys, is if and only if you have found that first, okay? You have to find that in order to see where your parabola locks in, okay? It has to lock in somewhere. So let's do this one. Let's do y equals, let's go 2x squared plus 12x plus 14. Okay, so let's start the same way we've been starting. Find A, B, and C. Okay, so A is 2, B is 12, and C is 14. Okay, so if A is 2, B is 12, and C is 14, in order to find our max or min point, okay, in order to find our vertex, we have to find our axis of symmetry first. So x equals opposite B divided by 2a. So opposite B, 12. So what's opposite? Negative 12 divided by, we have 2 times 2. So we have negative 12 divided by 4, which is negative 3. Okay, so we just found out that our axis of symmetry is negative 3. So our parabola is being folded in half at x equals negative 3. 1, 2, negative 3. So right here, okay, that's where our axis of symmetry is at. So now we need to ask ourselves, are we going to try to find the max point or are we finding the min point? So go back to your A. If A is positive, it's concave up, okay? So again, we are trying to find the midpoint. So the question is, where does this lock in on that fold line, okay? Where does our parabola lock in? And if we find where it locks in, then that means we found the midpoint, which means we found the x comma y, which is our vertex, okay? So if we're trying to find what this y value is, take our x that we just found and plug it in, okay? Seriously, guys, do not overcomplicate this. I know you can do it, okay? You got it. So y equals 2 times negative 3 squared plus 12x plus 14. Okay, so then now you go through and you follow the order of operations. So remember, you have to do that first, okay? So negative 3 squared. So if I have a negative times a negative, that's going to give me a positive. So this is just going to be 2 times 9. 2 times 9 is 18. Okay. Plus 12 times negative 3. Whoops. Forgot to plug that bad boy in. Okay. So then 12 times our negative 3 is negative 36 plus 14. So then we have our 18 minus 36, which is negative 18. Watch your signs, guys. Use your calculators if you need them. Plus 14. And then negative 18 plus 4 is, again, negative 4. So if we just figured out that negative 4 equals y, we figured out that this parabola locks in negative 1, negative 2, negative 3, negative 4. Okay? We found out that it locks in right there at negative 4. So this vertex, okay, our minimum point is negative 3, negative 4. And we know somehow it's going to go up, okay? We're going to cover this later to figure out exactly where it crosses that x-axis, but for right now, we're just trying to find that vertex. Okay, let's do one more of finding the vertex, okay? So I have y equals negative x squared minus 2x minus 2. Okay, so just like we did on the last two, find your a, find your b, and find your c, okay? So a equals negative 1, b equals negative 2, and c equals negative 2, okay? So if we wanted to, before we even started, we can look at our a, and we can tell, oh, this is negative, so now this one is concave down. So if this is concave down, are we finding the max point, or are we finding the midpoint? Okay, so for this one, we are now finding the max point. So our y inside of our vertex, the x comma y, is now a maximum point. But the way to find it does not change. You have to find the axis of symmetry. So you have to find that fold line, and then we have to lock it in on that line. Okay, we have to see how high does it top out at. Okay, so we have x equals opposite b, so if our b is negative 2, opposite is 2, divided by 2 times negative 1. So we have 2 divided by 2 times negative 1, which is negative 2. So our x equals negative 1. So again, we just found out that our axis of symmetry, so our parabola is being cut in half on this line right here. Okay, so the question is, where is our parabola going to top out? Okay, where is it going to be the max, as high as it can possibly go? Okay, so let's take our x that we just found to spit out our y. Our y is going to lock it in at the top of our parabola, okay? So we're going to take it, we're going to plug it in, and we're going to plug it in. So I have y equals negative, now we're going to plug it in, negative 1 squared minus 2 times negative 1 minus 2, okay? So I got to follow the order first. So negative 1 squared is 1, and then we tack on the negative. So negative 1, Negative times a negative is a positive. So plus 2 minus 2. Okay, so we have negative 1 plus 2, which is our 1. We have 1 minus 2, which equals negative 1. So we just found out that our y point inside of our vertex is negative 1. Okay, so our vertex is negative 1, negative 1. Okay, so we figured out that our parabola is going to top out right there. Okay, again, we know that it's a max because that's a negative, which means it's concave down, which means we have the top. So our vertex is negative 1, negative 1. Okay, so what you are going to do again is you are going to practice with quadratic equations. Okay, so I'm not going to give you a graph. However, if I do just give you a graph, so if you have something that looks like this, here's your graph. Let's go 1, 2, 3, 1, 2. So if you have a parabola that looks like that, could you identify your vertex and tell me what that vertex is? Well, let's see. It folds in half here, x, and then our y is 2. So our vertex would be 2, 2. Okay, so if I do give you a picture of a parabola, I hope that you can just identify the ordered pair that the vertex is sitting on. Okay, so right now we're really just going to focus on can you find it mathematically. So you are going to do a sort on Google Classroom. Okay, and then you're going to sort the shamrocks in concave up or concave down, and then you're going to find the vertex and then type it in the box. Okay, so again, if you have any questions, if you need me, feel free to reach out and send me an email.